Before Russia can advance, Russia must prepare the ground. That preparation is not only in the fires that suppress Ukrainian defenders. It is in the engineering work that clears the mines in front of Russian assault formations and lays new mines on the flanks to protect advancing units from Ukrainian counterattacks. Russian military engineering is the unglamorous, operational backbone of every offensive operation on the Eastern Front. Remove it, and Russian assault planning collapses. Assault formations that cannot breach Ukrainian minefields without engineering support cannot reach Ukrainian positions, and Russian flanks that cannot be protected by fresh mine barriers are exposed to the Ukrainian counterattacks that have repeatedly reversed Russian gains. Days ago, in the middle of April, Ukrainian forces struck at exactly that backbone. A Ukrainian reconnaissance drone identified a Russian engineering column in eastern Ukraine, mine-clearing vehicles, PMZ mine-laying systems, armored bulldozers, moving toward the positions where Russian commanders were preparing for a renewed offensive push. Ukrainian artillery crews and FPV teams, already positioned and pre-registered, engaged the column before it reached its destination. The column was destroyed completely. The engineering preparation for the Russian offensive push that was building in the sector was set back by days, and the assault formations that were waiting for the engineering work to be completed found themselves waiting for engineering assets that were no longer coming. This is the story of that strike, and this is what it cost Russia, not just in equipment, but in the operational sequence that the equipment was part of. Understanding why destroying an engineering column is as operationally significant as destroying an armored column requires understanding how Russian offensive planning in eastern Ukraine actually works. The specific sequence of actions that must occur before Russian assault formations can move forward, and where the engineering phase fits in that sequence. Russian offensive planning in the current conflict follows a recognizable pattern. Fires preparation comes first. Artillery and rocket systems work to suppress Ukrainian defensive positions, degrade Ukrainian observation and counter-battery capability, and reduce the combat effectiveness of the defending force before the ground assault begins. Engineering preparation runs in parallel. Mine clearance systems work to create lanes through Ukrainian minefields on the approach routes, while mine-laying systems prepare barrier mines on the flanks of the intended axis to prevent Ukrainian forces from counterattacking into the assault forces' exposed sides. Only after both fires preparation and engineering preparation have been completed to the satisfaction of Russian assault commanders does the ground assault begin. This sequencing means that the engineering assets are both critical to the operation and time-sensitive. The mine clearance lanes created by Russian engineering must be marked and maintained for the assault formations to use them. Fresh mine contamination from Ukrainian mine-laying drones and artillery-delivered mines can close a cleared lane faster than Russian engineering can reopen it. The flank barrier mines must be in place before the assault advances past the points they are designed to protect. Engineering preparation that is not completed before the assault begins is preparation that creates the conditions for assault failure. Ukrainian intelligence teams tracking Russian offensive preparation in the sector had identified the engineering column as it assembled. The specific vehicles, the UR-77 mine-clearing systems with their line charges, the PMZ mine-laying vehicles with their cassette mine dispensing systems, the IMR combat engineering vehicles with their bulldozer and crane attachments, were identified from drone observation imagery and confirmed against the known profiles of Russian engineering equipment that Ukrainian analysts had cataloged through the conflict. The column's movement direction and its assessed destination correlated with the developing picture of Russian offensive preparation in the sector that Ukrainian intelligence had been building over the preceding days. The decision to engage the engineering column, rather than allowing it to reach its destination and engaging it there, was based on a specific operational logic. Engaging the column during movement before it dispersed to its individual working positions, before the vehicles separated across the terrain to begin their specific tasks, meant engaging a concentrated formation that offered multiple targets in a defined geographic area. Once dispersed, the individual engineering vehicles would present individual targeting problems, each requiring separate surveillance and separate fires coordination. The column presented an opportunity to destroy the entire engineering capability in a single coordinated engagement. Ukrainian artillery had pre-registered against the route that the engineering column was using, The same approach that Ukrainian counter-battery teams had used against the Tornado G battery applied now to the engineering column. The road network in the sector constrained the engineering column to a predictable route, and pre-registration against the likely route had been conducted as part of routine fires planning that covered all significant movement corridors in the sector. When the column entered the pre-registered zone, fire mission execution was a matter of activating data that artillery crews had already prepared. The first artillery salvo landed in the column's middle, not at the lead vehicle, which the shoot and scoot experience of Russian tactical drivers had taught them to watch for and evade, but at the center of the column, where the engineering vehicles were most concentrated. The PMZ mine-laying vehicles, the highest priority targets because their mine cassettes represented the direct threat to Ukrainian defensive freedom of maneuver that the column's destruction was intended to eliminate, were caught in the middle of the formation by the first salvo. Two of the three PMZ vehicles were struck in the initial artillery fires. The mine cassettes they were carrying detonated in secondary explosions that were significantly larger than the artillery impact alone would have produced. The mine cassettes contain hundreds of small mines, each with its own explosive content, and the sympathetic detonation of those mines, when struck by artillery, created a secondary explosion that added substantially to the destruction in the column's center. FPV drones, launched as the artillery was still firing, engaged the engineering vehicles that the initial fires had not immediately destroyed. The UR-77 mine-clearing vehicle, carrying its large rocket-propelled line charges, was targeted specifically because the line charges, if detonated, could create a secondary explosion large enough to damage additional vehicles in the column. The FPV strike on the UR-77 initiated exactly that secondary detonation. The line charges erupted in a column of fire that was observable from Ukrainian observation positions several kilometers away, and that destroyed or damaged two additional vehicles in the immediate vicinity of the UR-77. The IMR combat engineering vehicles, the armored bulldozers that provide Russian assault formations with the ability to push through obstacles and clear debris, attempted to leave the road and move off to the side, using their bulldozer attachments to push through the field margins and escape the confined road environment where they were engaged. The April ground conditions, the soft, saturated soil that Ukrainian planners had incorporated into their fires, planning throughout this engagement series, held the IMR vehicles after short distances off the road. Mired on soft ground, they became static targets for additional FPV engagement. Both were struck and destroyed. The engineering column was gone. Every vehicle in it was either destroyed outright or immobilized and subsequently destroyed. The engineering preparation for the Russian offensive push in the sector had lost the assets it depended on. Now let us examine what Russia lost. The UR-77 mine-clearing vehicle, a specialist system that uses rocket-propelled explosive line charges to clear paths through minefields, carries a replacement cost of approximately $3 to $5 million USD per unit. These are not common vehicles. Russian forces have a limited number of UR-77s available in the theater, and each one lost reduces Russian ability to conduct minefield breaching operations against Ukrainian defensive lines. Without effective minefield breaching capability, Russian assault formations cannot advance through the Ukrainian mine barriers that have proven to be among the most effective defensive tools in eastern Ukraine. The UR-77 is not simply a vehicle. It is the capability that makes armored assaults through mined terrain possible. The three PMZ mine-laying vehicles destroyed each carry a replacement cost of approximately $1.5 to $2 million per unit, plus the value of the mine cassettes they were carrying. Each PMZ typically carries enough mine cassettes to lay a barrier of several hundred mines, with a mine cassette cost of approximately $500,000 to $800,000 per full load. 3 PMZs with full cassette loads, $6 to $8.4 million in vehicle and cassette costs. The two IMR combat engineering vehicles, $2 to $3 million each, for a combined $4 to $6 million. Additional vehicles in the column: logistics trucks, command vehicles, escort elements, $1 to $2 million combined. Total direct material cost, $14 to $21.4 million USD. Destroyed before any of it could be used for its intended purpose. The operational cost of this loss is more significant than the replacement value. Russian offensive planning in the sector required the engineering preparation that this column was carrying. Without the UR-77 to clear Ukrainian minefields, the assault formations that were being prepared to advance cannot reach Ukrainian positions without accepting casualties to mines at rates that Russian assault doctrine is designed to avoid. Without the PMZ mine-laying capability, the flanks of the intended assault axis cannot be protected by fresh mine barriers, leaving those flanks exposed to Ukrainian counterattacks. Russian commanders must now choose between proceeding with an assault without adequate engineering support, accepting higher casualties and greater flank exposure, or delaying the operation until replacement engineering assets can be sourced, moved forward, and positioned. In mid-April conditions, with the operational window that Russian commanders were attempting to exploit, delay has its own costs. Ukrainian defenders use every day of Russian delay to improve their positions, reinforce their lines, and prepare for the assault they know is being planned. The Ukrainian drone operator who identified the engineering column, the artillery crews who pre-registered against the route and executed the first salvo, the FPV operators who completed the engagement, they did not simply destroy vehicles. They disrupted an offensive sequence at its enabling phase, removing the engineering capability without which the assault it was supporting cannot proceed as planned. Russia cannot assault what it cannot reach. It cannot reach through minefields without mine-clearing equipment. Ukraine destroyed the mine-clearing equipment before it could clear a single mine. The offensive preparation in the sector is set back. The engineering column is gone. And the Ukrainian minefields that the column was sent to clear are still intact, still defending the approaches to Ukrainian positions, still doing the work of stopping Russian armor that they were designed and placed to do. Ukraine strikes the tools before they can be used. Ukraine destroys the preparation before the assault begins. Ukraine holds the mined ground that protects its defenders. The engineering column burned in the middle of April on a road in eastern Ukraine. The minefields ahead of it are still there, and the Ukrainian positions beyond those minefields are still held by the soldiers the mines were placed to protect. To fully understand what this engagement represents in the broader context of the conflict, it is necessary to examine the specific role that mines have played in Ukrainian defensive strategy, and why the destruction of Russian mine-clearing capability is so consequential for the balance of the ground battle on the Eastern Front. Ukrainian defensive mining has been one of the most operationally significant elements of the conflict in eastern Ukraine. Ukrainian military engineers and the infantry units they support have laid millions of mines across the approaches to Ukrainian defensive positions. Anti-tank mines that disable and destroy armored vehicles, anti-personnel mines that impose casualties on dismounted infantry, and the newer drone-delivered mines that can be placed rapidly to close gaps in mine barriers that Russian forces have breached. The depth and density of Ukrainian mining along the Eastern Front has been documented extensively through the rate at which Russian armored vehicles, including many of the tanks and IFVs that appear in engagement footage, are immobilized by mine strikes before they are finished by subsequent fires. Russian military planners understand this. The mine barriers that Ukrainian engineers have created are one of the primary reasons that Russian armored assaults have consistently struggled to maintain momentum through the contact zone. A Russian armored column that enters a minefield without adequate breaching support will lose vehicles to mine strikes at a rate that consumes combat power faster than the assault can generate tactical progress. The operational solution to this problem, the reason Russian engineers exist, and the reason the UR-77 and PMZ vehicles are in the Russian inventory, is to breach lanes through Ukrainian minefields before the assault begins, and to lay protective mines on the assault's flanks to prevent Ukrainian counterattacks from exploiting the exposed sides of the advancing formation. When Ukrainian forces destroy Russian mine-clearing capability, they are not simply destroying vehicles. They are maintaining the defensive effect of every mine that the cleared vehicles would have been used to breach. Every Ukrainian mine that survives because the UR-77 that would have cleared it was destroyed before it reached the minefield is a mine that will continue to threaten Russian armor attempting to advance through that field. The multiplication of the effect, the number of mines whose defensive contribution is extended by the destruction of one clearing vehicle, is the operational leverage that makes targeting engineering columns as high a priority as targeting artillery or armor. Ukrainian military planners understand this leverage and have incorporated it into their targeting priorities. The intelligence effort devoted to tracking Russian engineering assets, the pre-registration of fires against engineering movement routes, the positioning of FPV teams to engage engineering vehicles. All of this reflects a deliberate targeting approach that prioritizes the destruction of Russian combat enablers alongside the destruction of Russian combat vehicles. Destroying a UR-77 prevents not just the loss of one vehicle, but the breaching of a minefield that may stop dozens of armored vehicles. The specific vehicles destroyed in this engagement illustrate the operational logic clearly. The UR-77, with its rocket-propelled line charges, is the primary Russian system for rapid minefield breaching under fire conditions. Its line charge, a rocket-propelled explosive hose that is fired across a minefield and then detonated to clear a path by sympathetic detonation of mines along the charge, can clear a breach lane through a minefield in a matter of seconds, fast enough to be used under fire as part of a moving assault. Without the UR-77, Russian assault formations attempting to advance through Ukrainian minefields must use slower, more methodical breaching methods that are conducted under fire, take longer, and expose engineering personnel to the Ukrainian defensive fires that Ukrainian commanders direct, specifically at the breaching operation. The PMZ mine-laying vehicles serve the complementary function. Russian offensive operations that advance through Ukrainian defensive lines need to protect their flanks from Ukrainian counterattack. If Ukrainian forces can attack into the sides of a Russian penetration, they can cut off the leading elements and restore the defensive line before the penetration can be exploited. Flank mine barriers, rapidly laid by PMZ systems as the assault advances, are the primary Russian response to this threat. Without PMZ capability, Russian flanks are protected only by the terrain and by whatever infantry can be positioned to cover them. A much weaker protection than a mine barrier, and one that Ukrainian counterattack forces have demonstrated they can overcome. The destruction of the engineering column, therefore, has a compound operational effect. It reduces Russian ability to breach Ukrainian minefields, making the cost of each assault attempt higher. It reduces Russian ability to protect the flanks of any penetration that is achieved, making any breakthrough more vulnerable to Ukrainian counterattack. Both effects work together to increase the probability that Russian offensive operations in the sector will fail, either stopped at the minefield they cannot breach efficiently, or reversed by counterattacks against flanks they cannot protect adequately. Russian engineers who assembled the column that was destroyed in this engagement were preparing to solve exactly these problems for their assault formations. They were doing the work that Russian offensive doctrine requires before an assault can proceed. Ukrainian forces destroyed the tools of that work before it could begin. The operational delay imposed by the column's destruction, the additional days required to source replacement engineering assets, move them forward, and position them for the same preparation sequence, is measured in time that Ukrainian defenders will use. Ukrainian engineers will improve mine barriers. Ukrainian infantry will improve fighting positions. Ukrainian counter-battery teams will continue their attrition campaign against Russian fires assets. Ukrainian drone operators will continue finding and engaging the targets that degrade Russian offensive capability across every domain. Every day of Russian offensive delay is a day that the Ukrainian defensive system grows stronger, and the Russian offensive capability that is being accumulated to overcome it grows weaker. The engineering column was the preparation phase of a Russian offensive sequence. Ukrainian forces destroyed the preparation phase. The offensive sequence cannot begin without it. And while Russia works to reconstitute the engineering capability it lost in mid-April, Ukraine works to ensure that the defensive position the engineering was supposed to breach is harder than it was the day before. Russian engineers build the tools to break through Ukrainian defenses. Ukraine destroys those tools before they can be used. The minefields stand. The positions hold. The assault that was being prepared has not started. Ukraine strikes the preparation. Ukraine holds the ground. Ukraine defends with every mine that Russian engineering was sent to clear, and failed. The column is gone. The mines remain. The front holds on the far side of the fields that Russian engineers will now have to find a different way to cross. There's a final dimension of this operation that belongs in the record. The dimension that connects the destruction of an engineering column to the Ukrainian soldiers in the defensive positions that the engineering was supposed to help Russia reach. Ukrainian infantry in defensive positions in eastern Ukraine live with the mines they placed. They know where the mine barriers are. They know the lanes through them that allow friendly forces to move in and out. They know the fields in front of their positions are mined because they or their colleagues placed those mines, often at night, in conditions that made the work dangerous and the navigation demanding. Those mines are not just physical objects. They are confidence. The knowledge that the open ground in front of a defensive position is not freely traversable by Russian armor. That a Russian armored assault attempting to advance across that ground will encounter a barrier that slows and disrupts it before it reaches Ukrainian positions. That confidence shapes how Ukrainian defenders fight, how they manage their ammunition, how they position their direct fire weapons, how they calculate the time available to call fires and receive artillery support before an assault force reaches the wire. When the UR-77 that was supposed to clear a lane through that barrier was destroyed before it reached the minefield, the mines remained, and the confidence they represent remained with them. Ukrainian defenders in those positions may never know that an engineering column was destroyed on a road several kilometers behind Russian lines. They will know when the assault they are waiting for either does not come or comes against minefields that have not been breached, that something worked in their favor. The Ukrainian drone operator who spotted the column, the artillery crews who fired the pre-registered salvo, the FPV operators who completed the engagement. They were protecting soldiers they will never meet, in positions they may never see, by destroying equipment that those soldiers were counting on never having to face. That is the network of protection that Ukrainian military operations weave across the Eastern Front. Visible in some places, invisible in most, but real in all of them. Ukraine destroys what threatens its defenders. Ukraine holds with every mine that continues to stand between Russian assault formations and Ukrainian positions. The minefields hold, the positions hold, Ukraine holds.